our Professor Math videos. Let's practice some exponents. Let me show you some practice on exponents that is extremely helpful. The only way to learn this is to do it. Okay? Let's say we have 10 times 10 to the fourth. Now, any number by itself has an exponent. Any number. It's just multiplied by itself once. So that's a 1. So the proper way to multiply this, remember, multiplying, we add the exponents, right? So this is going to equal 10 times, to the fourth power plus 1, because this is technically 10 to the first. So this is 10 to the fifth. And that's your answer. That's simple, isn't it? No problem. What if we're given the expression 3 to the O plus 3 to the O? What do we do in that instance? We know any power, any number to the power of 0 just equals 1. So this is 1 plus 1 equals 2. Piece of cake, right? What if we have 8 to the second plus, times 8 to the fifth? What do we do in this instance? Because 8's a pretty big number. 8 times 8 is 64, and 8 times 5 is way up there in the thousands. We don't have to worry about calculating them first before getting to the answer, however. When a number is multiplied by itself with the exponents, it's simply 8 to the second power plus the 5. And so this equals 8 to the 7th. And that's your answer. That's a very appropriate answer. If you want to use your calculator and multiply 8 out 7 times to get the actual number, you can. But this is also the proper answer, 8 to the 7th. It's that simple. Now, what if we are given 19 to the fifth over 19 to the second? In a division, remember, we subtract the exponents. So this becomes 19 5 minus 2. So this equals 19 to the third. It's that simple. It is truly that simple. Let me erase this so that we have a little more space here. I got to learn how to write smaller, huh? I'm just worried you guys aren't going to be able to see this board. Let's say we have 6 squared and that whole expression taken to the 5th power. You remember what to do here. Now remember, this is saying 6 times 6 here, and this is saying do 6 times 6 in 5 sets. So what we do is we multiply the exponent. This is simply 6. 5 times 2 is 10. 6 to the 10th. You no longer have to be intimidated with materials like this. It's very easy to do. If we had something like, and here's where you can invent your own problems. Just change the numbers, and then solve for the real number instead of leaving it in exponent form. You could have 3. You could have 3 to the third, and take that to the 9th, if you wanted. And as long as you recognize and talk to yourself when you do this, this is 3 to the third. This whole expression, 3 times 3 times 3, is supposed to be multiplied 9 more times. So you know it means you multiply the exponents. 9 times 3 is 27. That's 3 to the 27th. And this is up into the billions, if not trillions. This is a gigantic number. It really is. That is huge, truly. So you can invent your own and play with them. What if we have 4 to the 4th divided by 4 to the 3rd? Now you'll see it written like this sometimes. What I personally like to do, and this is strictly your personal preference, I always like putting the fraction bar in. For whatever reason, my visualization is easier when I make this 4 to the 4th over 4 to the 3rd. Same thing. Same expression. Now I know in division, this is going to be 4 to the 4th minus 3. So this is going to equal 4 to the 1st, which simply equals 4. Any number to the 1st power is just that number. But see, it looks complicated, but it's really not once you know the rule. It's really not that difficult to work with. Let's do another one. Let's say we have 3 to the 10th divided by 3 to the 3rd. See, it'll work with any number. You can practice with absolutely any number you want, right? We know this means 3 to the 10 minus 3, so this goes to 3 to the 7th. And then you can calculate that number out and give the number if you want. It's that simple. What if we have x cubed times x to the 8th? What do we do in that instance? Well, we have a variable that's to a power times a variable to the power. So we know we're going to add the exponents. We multiply the base, but we add the exponents, and this is 3 plus 8. You don't have to do it this way every time. I'm just doing this way to show you the rule. So this is x to the 11th. It's just that quick and easy. Now what if we had an eraser and I could erase this so that we have more space? Yeah, that's the ticket. That'll work. What if we're given the expression y to the 4th and that whole expression taken to the 4th power? Here we have a variable. We get used to working with variables. This is simply y. You multiply the exponents. Boy, if this will write, this is y to the 16th. It's truly not any more complicated than that, man. It's really not. What if we have an expression where we have x y to the 9th times x to the 5th y to the 3rd. Now you're starting to say, oh, wait a minute, you're combining variables and some of them have exponents and some of them don't. I don't know how to do this. Yes, you truly do. It's very simple. We have a multiplication of an xy and an xy. So we know we're going to add the exponents. Keep the base, add the exponents. Right? So one step at a time, do one variable at a time. Put down x, add, remember this is x to the 1. Any variable by itself has that one exponent. Just as surely as any variable by itself is over 1, just like that also. It can be a fraction, it's automatically a fraction, but it's automatically an exponent also in any number or any variable. And you want to keep that in mind so that you can do the proper counting. Because this is not going to be x to the 5th, this is going to be x to the 5 plus 1. And then you do the same thing with the y. 9 plus 3. So that this simply equals x to the 6th, y to the 12th. And that's your answer. You can't combine the different variables, so you leave it just like that. So see, that's not that complicated, even though you have an x and a y times an x and a y, and you have different exponents, it's okay. Simply put it down and do your adding of exponents and get your answer. It's not that complex, is it? In fact, it's not complex at all. Let's do some negative exponents. A to the negative m. Now we're given a negative exponent. You remember the idea here. This is telling you that this is 1 over a to the m power. You put the a to the m as the denominator in a fraction and take away the negative, and that's your proper answer. This will be very valuable to know. It's also very valuable to know if you're ever given an expression of 1 over 5 to the second. You know that 1 over 5 to the second equals 5 to the negative 2. It goes backwards, back and forth, right? This is very valuable to know. This will help you solve very difficult equations, knowing how to go back and forth from a negative exponent to a fractional, and from a fractional exponent to a negative. This is very valuable to know, and we will be able to practice this a lot, I promise. And it makes it simpler to solve equations. What if we're given 5 to the negative 2? Let's work this thing all the way out. We know automatically that this is going to be 1 over 5 squared. And we know this means this is 1 over 5 times 5, so that we know this is 1/25. It's that simple. And you know automatically you can take this backwards. If you have 1/25 as a fraction to begin with, and you need it in exponent form, you know that you can put this into an exponent form here, and you know, since you're in the denominator, you can move that little baby up, and when you move it up atop above the fraction bar, it becomes a negative. Just like when it starts as a negative, you see technically this is 5 negative 2 over 1, isn't it? So you know if you switch this, you go 1, and this is 5 squared. It becomes a positive. You can go backwards and forwards, and this becomes very, very valuable. Very valuable indeed in helping us solve equations. Let's do another negative exponent that is really interesting. What if we're given negative 3 to a negative 2? Now think this through, what it's telling you. We know the rule with a negative exponent. But instead of a positive number, we have a negative number. But doesn't it make sense that we can put 1 and negative 3 to the positive 2? It's not the negative number that changes its sign, it's the exponent that changes its sign when we put it into the fraction. So now this is equivalent to saying 1 over negative 3 times negative 3, right? You have 2 negative 3's to multiply together. And what does that equal? That's simply 1 over negative 3 times negative 3. A negative times a negative is a positive. So negative 3 times negative 3 is simply 9. And that's your answer, 1/9. That's kind of cool, isn't it? What if we were told we had a negative 4 and this was to the negative 1? What do we do in that instance? Oh, I lied. We're going to multiply this by negative 4 to the negative 2. So now we have an actual equation here. Negative 4 to the negative first times the negative 4 to the negative second. This becomes, Remember, we're multiplying, so this becomes negative 4 to the negative 1 plus negative 2. We add the exponents when we multiply something that's taken to the power. You remember that? So this becomes negative 4 to the negative 1 plus the negative 2. So this is negative 4 to the negative third, right? And what's this tell us when we have the negative exponent? This becomes 1 over 4 to the third, doesn't it? Negative 4, sorry. We keep our negative. We have to keep our negative. This equals negative 4 times negative 4 times negative 4. So that this becomes 1 over negative 64. Negative 4 times negative 4 is positive 16. Positive 16 times negative 4 is negative 64. We have an odd number of negatives, 3, therefore it'll be negative. So that's how that works with exponents, negative exponents, taking them all the way. When you're dealing with a negative exponent, you're simply dealing with fractions. Now that's valuable to know. And when you're dealing with fractions, you're actually working with negative exponents, the opposite of the negative exponent. This helps us really powerfully in solving lots and lots of really tough math equations, but once you know how to manipulate stuff like this, the tough equations become quite simple, and that's cool to know. All right, I do believe I've still got some time, and I've got some other. Evaluate when x equals 10. Let's do some more of these. These are always valuable. You need to start doing these by the thousands, because you will love these. Boy, that sun is glaring, isn't it? Boy, that's a lot better. Holy crap, I wish I'd have saw that an hour ago, huh? So let's say we have 5x divided by 14 minus 9. Now we can rewrite this, and I always like rewriting this. This is the exact same thing, 14 minus 9. I personally like to put it into the fraction bar. I don't know why, that's just my personal preference. You might want to do it this way. Well, we're told x is 10, so we know this becomes 5 times 10. Right? Over 14 minus 9. So we know that this is going to be 50 over 5. So that we know 5 into 50 goes in 10 times. So the answer to that expression is simply 10. See, that's not too difficult, even though we're doing variables. We'll learn how to do variables very easy, very fast. Let's say we have 25 minus x, and this is divided by 10 minus 5. So this becomes 25 minus 10, because that's what we're told x is, divided by 10 minus 5 is 5. So 25 minus 10 is 15 over 5, and you know 5 goes into 15 3 times. It's that simple when we're working with variables in fractions or not in fractions. It doesn't matter. We can work these because we're learning how to do the rules of algebra. And it gives us the possibility of doing all the expressions very easy. What if we're given the expression x plus 6 plus 9? X is 10. That's simply 10 plus 6 plus 9. That's simple. That's 25. See, sometimes there's nothing to these, but that's the idea. What if we're told x plus 32 as a part of the expression, and then that's divided in itself by x? So x plus 32, this is going to be, I'm going to bring it up here, 10 plus 32 is simply 42, and 42 is divided by x, which is divided by 10. So again, we see our improper fraction. The numerator is greater than the denominator, so we divide the denominator into the numerator. And what's 10? How many times does 10 go into 42? 4. What's left over? 10 times 4 is 40. The difference between 42 and 40 is just 2. So you put 2, you bring over your denominator. We know that both of the numerator and denominator here are even, so we know that's reducible. You take 2 out of 2, leaves you 1. You take 2 out of 10, and it leaves you 5. So this becomes 4 1/5. It's just that simple. Just step-by-step application of every property and rule and operation that we're learning in algebra, and all of a sudden, you're doing algebra. It's that simple. What if we're given the expression 3x minus 6 divided by 7? You notice we're doing a lot of division, we're doing a lot of fractions. That's because math ultimately becomes mostly fractions. So it's best to get used to it now, because we'll be doing it a ton later, especially in trigonometry and calculus. And that's the fun of it. There are parts of the whole. Hey, welcome to reality. 3x. This is telling us we have 3 multiplied by 10. I'm going to use brackets just for kicks and giggles. Minus 6. This is in parenthesis. That's why I used brackets. And this is over 7. This is the same expression, putting it under the bar, as you do this. This doesn't help me nearly as much as putting it in fraction. And I suspect you'll see that as we go along. So what's 3 minus 10? 30. Minus 6 over 7. 30 minus 6 is what? 24 over 7. 7 goes into 24 how many times? 7 times 3 is 21. 7 times 4 is 28. So 28's too big, so it's 3, right? So this becomes the mixed number 3. And the difference between 24 and 21 is 3 sevenths. 3 and 3/7. It is sincerely that simple to do algebra. Now, if I'm going too fast, or if I'm not doing enough of one kind of problem or another, let me know in the comments below the video, and I will be happy to do as many practice videos as you want me to for you. I promise. It's great review for me. Let's say we have 4x divided by x. Now this is simple when you look at it. You know the x's are just going to cancel, right? So you don't have to freak out by saying, oh man, I have a variable and it's being divided by a variable. We're given the answer is 10. Let's work it out just to prove it to ourselves. 4 times 10 divided by 10. This is going to equal 40 divided by 10. What does 10 go into 44? 4 times. So that's simply 4. It's the same thing as if we would have just said, cancel the x's. There's your 4. Right? But we can see working it out the issue here. Now if you had something like this, 4x plus 3 over x, now we see that changes. 4 times 10 is going to be 40, plus 3 is going to be 43. X is 10. We have 43 tenths, an improper fraction. 10 goes into 43 how many times? 4. What's the remainder? What's the difference between 43 and 40? 3. 4 and 3/10, right? So 4 and 3/10. There's your mixed number. You multiply these two together and add this one. Denominator down. 4 times 10 is 40, plus 3 is 43/10. As we begin to combine operations, it gets easy and it gets fun. Let's do one more. Let's say x is going to equal 4, just for kicks and giggles. And we have 3x plus 2x minus 9x times 5x. And you go, holy cow, dude. Remember the order of operations. Multiplication and division first, adding and subtracting last. We go from left to right, but here's where your parentheses are your friends. We have a multiplication right here, so put the parenthesis around that multiplication every time. Now you know that's the first operation you do. But we can fill in the x. 3 times 4 plus 2 times 4 minus 9 times 4 times 5 times 4. There. Now we filled in the variable. Now we do the operations, but we do it in order, so we're going to evaluate what's in the parenthesis first. Always, always, always in parenthesis first. 9 times 4 is 36. Times 5 times 4 is 20. Oh boy. 36 times 20. Well, 360 and 360 is 720. This should be 720. I'm going to go ahead and multiply it out. Yep, 720. Now, we want to keep our parenthesis because this is being subtracted from these numbers. So this is 12 plus 2 times 4 is 8, and this is 20. Subtract 720. So we can see that this is going to equal negative 700. Because the number 720 is larger than 20. However, we're subtracting the larger number from the smaller. And subtraction, I know I keep repeating this, but it helped me when I had it taught to me, so I'm going to do the same thing to you. The subtraction is the same thing as adding the negative. Since it's so much bigger, the answer is going to be negative. Now, I just pulled that right out of my head. This equation. You can do the same thing and then work it and practice it and then use your calculator and check. Hopefully I've done the math right here, otherwise I'm going to look like a real dingling, aren't I? Don't worry about making mistakes. Everybody makes mistakes. So anyway, that's all the time I have for now. Thanks for watching my videos. I hope you're getting something out of them. Let me know in the comments what you want me to cover in algebra. I know I haven't done square roots yet. We need to keep practicing more and more equations as I come up with equations or as I'm looking through my books. I own about 12 algebra books. I've been through a few of them. I'll grab some equations and put them down for you, and then I'll invent some of my own and we'll do our homework together. By doing math, we conquer math. We master math. Math does not master us. So, happy calculating, man. Have a great life, and I will see you in the next video.